We left off the previous screencast. We had done A and B on the back side of this limiting reactant worksheet. And so if you haven't already, please go ahead and pause the screencast and work out C, and then get A, B, and C balanced on the bottom and go ahead and work those out. I'm going to go ahead and give you the answers for those, but if you've not already done them, then you really won't know if you've got this or if you don't have this. So for C, X was equal to 7, and your limiting reactant was the CuCl2. So your after was 6, 0, and made was 21 moles and 14.0 moles of the AlCl3. All right, for A, that one balanced 2, 3, yields 3, 2. Your limiting reactant was the lead nitrate, and X, and that one was equal to 3.33. Sometimes, decimals freak kids out, but that happens. We start with these nice, easy numbers, but of course you're going to be given grams eventually, and you're going to have to convert to moles anyway. So that's totally fine that the numbers work out that way. So that means your excess reactant was your aluminum. After, you would have 1.34 moles of aluminum, and don't stress a whole lot about sig figs on this one. We'll work on that as we go. 9.99 moles of lead formed, and 6.66 moles of the aluminum nitrate formed. For B, this is a combustion reaction. Remember that the easiest way to balance those is alphabetically, C, then H, then O. And if you end up with an odd number of oxygens on the right-hand side, there's no way for this oxygen to be odd unless we make it a fraction. So the easiest thing to do is to go through and double it. So for this one, it balanced 2, 15, yields 12, 6. For this one, your limiting reactant came out to be O2, and your X was 1.33 moles. So the after, we would have none of the oxygen since that's limiting, 1.34 moles of the C6H6, and formed, we would have 16 moles of CO2 and 7.98 moles of water. For C, that one balanced 3, 2, yields 1, 6. Your limiting reactant on that one was CaOH2. Your X came out to 5.00. Your after, since CaOH2 is your limiting reactant, that would be gone. You would have 5 moles of the phosphoric acid left. You would have 5 moles of the calcium phosphate formed, and 30 moles of the water made. So if you did pretty well on those, feel free to go ahead and move on to the next page, which is a little bit more of the same, but also gets into a little bit of mass, but it kind of baby steps you through it. And then on the back side, there's a little bit more, I believe, where they start you with mass and you have to get to moles. So for this first reaction, they ask you to balance it. And this is a synthesis reaction. So to balance it, we're going to have to put a 2, a 4, and a 3. Alright, so they tell you they gave you 12 moles of iron. So you have 12 moles of this, and 24 moles of oxygen. Alright, so if we come through and we set up our little BCA table, we've got 4Fe plus 3O2 makes 2Fe2O3. So before, change, and after. Alright, so to begin with, we have 12 and 24. Okay, so we've got to come through and divide our given by the coefficient. So we would do 12 divided by 4, and we get 3 there. And then we would do 24 divided by 3, and we would get 8 there. So we take the lower x, so we cross that one out so we're not tempted to use it. So that means our limiting reactant is going to be our iron, and X is going to be equal to 3. So we know that all of our iron is going to get used up, and we'll have 0 left. We know that this is going to go down by a factor of 3x, and we know that x is equal to 3. So here we have 24 minus 9 So we get 15 moles. And then to begin with, we don't have any product. This is going to go up by 2x, and x again is 3. So we would have 6 moles formed. So the thing I love about these BCA tables is you've got everything you need. You've got the start of the reaction, you've got the end of the reaction, you've got how much excess is left over. So these questions that they ask later are very straightforward to answer. So it says, well, what is the excess reactant? Well, it's the reactant that you have something remaining when you get done. So that would be the O2. What's the limiting reactant? It's the reactant that you don't have any of, and the one that gave you the smallest x to begin with. So that would be iron. And then it says how much in both grams and moles of iron 3 oxide will be made. Again, you've got this nice table. You know how many moles are made. So to answer the first, well, actually the second question, that would be 6 moles of iron oxide. And then how are we going to get 6 moles of iron oxide into grams? Well, anytime you want to go from moles to grams, it's mole mountain. They've got moles there, grams here. Grams per mole, which comes from the periodic table, is going to be our conversion factor. So if moles are here, moles of Fe2O3 are going to go down, and grams are going to go up. And so for every 1 mole of Fe2O3, that molar mass is 159.6. Where did this come from? You go to your periodic table, you add up 2 irons and 3 oxygens, and you get 159.6. Alright, then we multiply our 6.00 by our 159.6, and we cut it to, looks like 3 sig figs. So our answer would be 958 grams. Alright, and then it says how much excess reactant is left over in moles. Again, right there in your table, so 15 moles of excess reactant remain. Alright, number 2 is very similar. So go ahead and pause the screencast. See if you can get it balanced and answer all the questions, and then click the screencast back on and check your work. So number 2 balances 2, 3, yields 2, another synthesis reaction. Our limiting reactant for this one turns out to be Cl2. You take the 18 and divide it by 2, you get 9 moles. You take the 14 and divide it by 3, that came out to 4.67. So that is our X. Get rid of that one. So for our, what is our excess reactant? That's going to be our aluminum. For our limiting reactant, that's our Cl2. How much in both grams and moles of aluminum chloride will be made? Up here in your BCA table, you got 9.3 moles of AlCl3 using the molar mass of 133.5 grams in a mole. You should have gotten about 1,200 grams for your answer there. And the last question asked how much is left over in moles, and that was, oops, that was about 8, around 8.7 moles from your BCA table up top. Alright, hopefully that went pretty well. We're moving on to a double displacement reaction here. Looks a little bit more involved, but really that's just because you've got 2 reactants and 2 products. Your BCA table works exactly the same. Our first step is going to be to get it balanced. So we've got 6, 1 yields 2, 3. They tell us we have 24 moles of this and 24 moles of this. And so, you know, I know sometimes students get into like this pattern of, oh, okay, I take the given, I divide by the coefficient, but I want you to think about what this means. You've got equal amounts of reactants, right? You've got 24 moles of both. And if you look at the coefficients, what this recipe is saying is it takes 6 moles of the sodium hydrogen carbonate for every 1 mole of barium phosphate. So think about that. If you had 6 moles of this, it would require only 1 mole of that. Well, you have equal amounts, right? So if you have equal amounts and you know it takes 6 times the amount of this, then hopefully you're starting to see that the NaHCO3 would be your limiting reactant. because you need 6 times the amount of this as you have of that, and you don't. They're actually equal to each other. So right away we know that our limiting reactant is the first one. But we'll go through what we do. 24 divided by 6, and we get 4.0. And then 24 divided by 1, and we get 24. We get rid of that. We know that this is our x. So we know in our table that our sodium hydrogen carbonate is going to be completely used up. So I'll recopy this real quick. All right, so B, C, A are given as 24, given as 24. These are both at 0. All right, this is going to go down by 24 because it gets completely used up. This is going to go down by just x, 1x, and x we said was equal to 4. So we're going to have 20 left of that. This is going to go up by 2x, so 2 times 4, so that would give you 8. And this is going to go up by 3x, or 3 times 4, so that will give you 12. All right, so there's our table. It asks what's the excess reactant, so that's the barium phosphate. What is the limiting reactant? That's the sodium hydrogen carbonate, or sodium bicarbonate. It says how much in both grams and moles of sodium phosphate will be made. So it's asking about this one right now. We know that 8 moles was produced, so that's the first part. And then to get that into grams, we're going to need the molar mass. Now, again, why are we saying 1 mole of sodium phosphate instead of 2 moles of sodium phosphate? Anytime we do these molar masses, right, we take them from the periodic table and we do them per 1 mole. So we add up that molar mass, it was 164.0. So we multiply that out and we get about 1310 grams. All right, then it's asking about this guy, the barium hydrogen carbonate. So first answer is 12 moles. And then we got to get that into grams by using its molar mass. So 1 mole barium hydrogen carbonate. Go to the periodic table, add those all up. Don't forget your 2 multiplier. So there's 2 hydrogens, 2 carbons, and 6 oxygens, plus a barium. That molar mass is 259.3. We multiply that through. We get about 3110 grams. Okay. And then how much of the excess reactant is left over in moles? We go back up to our table, and that would be 20.0. All right, go ahead and pause the screencast and take a look at this next problem. See if you can get started on it. It's starting you with grams and grams. And think about, can we take those grams and divide it by the coefficient? So the nice thing about this is it's all 1 to 1, right? But every time we've been dividing, we've always had it in moles. So moles there, moles in number 2, and moles in number 3. So what do you think you have to do if you're given grams? And you probably know by now the answer is always moles. So we're going to take our 25 grams, get that into moles, take our 30 grams of sulfur, get that into moles, divide by the coefficient, which, like I said, is nice as 1. So we're really just going to take the smaller number. So go ahead and pause this, work it out, and then come back and I will give you the answers. So for our grams of zinc, 25 grams of zinc is equal to 0.382 moles of zinc. And for the sulfur, 30 grams was equal to 0.935 moles. So I have to take my lower number. So that means zinc is the limiting reactant. How do you know? Well, when I took its moles and divided by its coefficient, it gave me the smaller number. And then how many grams of zinc sulfide will be made? Well, you've got this much zinc and that much zinc sulfide formed because everything's 1 to 1. Molar mass of zinc sulfide is 97.5. So your final answer comes out to 37.2 grams of ZNS.